Welcome back, YouTubers. Let's go ahead and finish up our small mini-series on elimination. Now, we have a system of equations, two variables in each equation, and two equations total, making it a system, and I can solve it because there's the same number of equations as there is variables. Also, they are both in standard form, tells me that I'm going to most likely be using elimination on this one. Now, this one looks a little bit different than the ones we've seen before. The first one that we covered, we had one of the variables, in this case the y, where they had the same coefficient with different signs. That made it so that whenever I added them together, I would get my 0y. That's the purpose of elimination, is to make that happen. In my second one, I didn't have anything that was exactly the same coefficient, but the 1 here and the 2, well, 2 is a multiple of 1. So I was able to multiply the bottom equation by 2, and hey, that forced it to eliminate. We also saw that we could have done it the other way around. This 1 and this 3 are, the 3 is a multiple of the 1. So I multiply the top equation by -3, I still get the exact same scenario. A different one would have eliminated. On this one, if we look at it, well, 3 and 5, that's not a multiple. 2 and 7, that's not a multiple either. So we've got to do a little bit of creative multiplication here. Now, I don't care what these coefficients end up being as long as I've got the same number with different signs. So what I'm going to do this time is multiply both equations. Now, the numbers you're going to multiply by is actually not that difficult to come up with. The 3, multiply that one on top. Take the bottom one up to the top. Take the 5 and put it on bottom. So these two are just going to switch places. Now, also I want to make sure that I have different signs whenever I finish. So it doesn't matter which one, but one of these two guys needs to be negative to force one positive, one negative when I get down here. Let's go ahead and distribute those. 3 times 5x gives me 15x. Oh, I have to do it on bottom and I didn't write it. Now 3 times 2y gives me plus 6y is equal to 3 times -1 gives me -3. Now distribute the bottom. -5 times 3x gives me -15x. -5 times 7y gives me -35y. Equal mark comes down. And then -5 times 11 gives me -55. Now we can see we have same number, different signs. Those will eliminate. Let's go ahead and review our acronym there. Eric does super manly tricks daily. E is eliminate. Add the two equations together. Those two canceled out. 6y plus -35y is going to be -29y is equal to -3 plus -55 gives me -58. Step 1 down. Now let's divide. Divide both sides by -29 by the number in front of the variable. Y is equal to, now if I can't remember that, I can go to my calculator, but 58 divided by 29 is 2, and the two negatives cancel out to make a positive, and I've got y equals 2. Step 2, done. Now step 3 is substitution. Again, doesn't matter which equation you use. I've used the top two for the last couple. Let's go ahead and use the bottom one. Let's say 3x plus 7y is equal to 11. Now remember, this one goes into where the y is. 3x plus 7, let's replace the y with a 2 in parentheses, equals 11. Substitution done. Next one, multiply. 3x plus 7 times 2 is 14, equals 11. Multiplication done. Now, T for transpose. And the transpose means move it to the other side and change the sign. That one went there. Let's go ahead and collect those. 3x is equal to 11 minus 14 gives me -3. Transposing is now done. Divide now by the number in front of the variable. Divide both sides by 3. Those two cancel. Leaves me x equals -1. division, done. Now I just have to write my answer in the appropriate format. Oh, let's get that to where you can see it. Write in the appropriate format, an XY coordinate pair, -1, 2, and we are finished.